Here we have a 4-variable Karnaugh map. So our Karnaugh map is going to have 16 squares. And we're going to find the sum of products, product of sums, and it's also going to use some don't cares. Now, each square in the Karnaugh map corresponds to a particular min term. We're going to number our rows and columns. So that's x1, x2, x3, x4. Didn't write it very well. But the same way that we always do, we're going to number them 0, 0, 0, 1, 1, 1, 1, 0, and then 0, 0, 0, 1, 1, 1, 1, 0. And so this square, for instance, corresponds to the min term x1 bar, x2 bar, because x1 is 0, x2 is 0, x3 bar, and then x4. x4 is 1, so it is not complemented. Now we can number these squares with their min term numbers, and you can figure them out, or you can look them up, or you can just remember. You have a copy of this table handy. And it goes like this: 0, 1, and then because we wrote these in a different order, we're going to skip down here to get 2, 3. And then 4, 5, and skip down to here to get 6, 7. And then we're going to skip this column over to this one and get 8, 9, 10, 11, 12, 13, 14, 15. So you don't have to memorize those. You can look them up, or you can just do it the way I did. And for this one, our don't cares are given with their numbers. So we can put the don't cares D for 9 and 12 and 14. But our expression up here is not given with numbers, so we have to figure it out. So this first one, x1 bar, x3 bar, and x4 bar, we're going to have ones in all the places where x1 equals 0, x3 equals 0, and x4 equals 0. Now this is a 4-variable Karnaugh map, and in a 4-variable Karnaugh map, if you have 3 variables in your term, that's going to correspond to a group of 4. So where x1 is 0, x1 is 0 in this column and this column, x3 is 0 here and here, and x4 is 0 here and here. And so the only places where they're all 3 0 are in this square and this square. Okay, I hope I said that it was a group of 2. I hope I said that right. Okay, so if you have 4 variables, that's a group of 1. 3 variables is a group of 2. 2 variables is a group of 4. And 1 variable is a group of 8. So now we're going to look at the next term in our expression. And the next term in our expression is x3, x4. So those are all the squares where x3 equals 1 and x4 equals 1. And that should be a group of 4. And that one's easy to see because that's this row right here where x3 is 1 and x4 is 1. And so that's this one. So we took care of this one. Now this next one has x1 equal to 0, x2 equal to 0, and x4 equal to 1. So that should be a group of 2. So x1 is 0 and x2 are 0 in this row, or this column, and x4 is 1 here and here. So we already have a 1 here, so we're going to put a 1 here. So now both of those have 1s. So we did that one. And the last one has 4 variables, so that's going to be a single square. So it's the single square where x1 equals 1, x2 equals 1, x3 equals 0, and x4 equals 1. So that's going to be right here, right here. Okay, so let me make sure this agrees with what I have in my notes. And it does. Okay, so we are now going to look for the best cover. So we want to have the biggest groups possible and as few as possible. So first, let's look for a group of 8. And we don't have a group of 8. Now remember, we can use D's as 1s if it helps us. If it doesn't help us, we don't have to. So now we're going to look for groups of 4. And I see 4 groups of 4, but we don't need all of them. So I am going to, let's see, so I want to look, so the 4 groups of 4 I see are this one, this one, this one, and this one that wraps around. So those are the 4 groups I see. Now I'm only going to need the ones that include something that none of the others include. So if we look at this column right here, we've got these ones are included both in this column and in this group. If we look at this row right here, we see that this one is only in that group. So we know we're going to need it. So let's get that one. That's essential. Okay, now let me see this one. This one appears to be only in the group that wraps around. So that's going to be this one. So now the only one we have left is this. Well, we have these over here, but they're not included in a group of 4. So we have this one right here, and it looks like we could include it either in this group or in this group. And both of those are groups of 4. It doesn't look like either one is better than the other. So I will do it. I will do this column because it looks like that's how I did it in my notes. Okay, so now we're left with these ones right here. They're clearly a group of 2. Can we make them a group of 4 in any sort of way? And the answer is no, we can't. So now we have our groups, and our groups of 4 should have 2 variables, right? And our groups of 3 should have 3 variables. Our groups of 2 should have 3 variables. And remember, we could only have done groups that had 1, 2, 4, or 8 things in it. And so we could not have done, for instance, if we wanted to, like this little group of 3 right here, or a group of 3 right here. So it has to have either 1, 2, 4, or 8. So I'm going to start with this row, because for me, things that are in rows or columns are really easy to do, because you can just read off the row right there. And so in this row, they all have x3 equal to 1 and x4 equal to 1, and x1 and x2 are different. So this is going to include x3, x4, plus. Now I'll look at this column. And again, I like the columns because I can just read it off the top. That one will be x1, x2. Now I'll read this group that wraps around. Those are a little harder for me. So x1 is 0 and 1, so they don't have x1 in common. x2 is 0 for both of them, so they both have x2 bar. And x4 is 1 for both of them, so that'll be x4. Plus, and let's get this last group of 2. This last group of 2, they both have x1 equal to 0. x2 is different. They both have x3 equal to 0 and x4 equal to 0. So this is our sum of products. Let me see if that's what I have here. Yep. And you would have gotten something different if you had done the different group, but it would have had the same truth table. So it would have still been correct. So let's do now the product of sums. So I'm going to make a new Karnaugh map because it'll just be easier, so it won't be as messy. But we set it up the same way. Zero, zero, 0, 1, 1, 1, 1, 0, 0, 0, 0, 1, 1, 1, 1, 0. And for our product of sums, the D's stay in the same place. So I still have the same don't cares. So I have this don't care, this don't care, and this don't care. Now, I will have zeros every place that I didn't have a 1 or a don't care. So I'll have a 0 here, a 0 here, a 0 here, and a 0 here, and a 0 here. Yeah. Okay, so now we want to cover this with as few circles and as big circles as possible. So group of 8, no. Group of 4, yes. Okay, so let's see. We have these two zeros left. Well, how can we get them? Well, this 0 is not included with anything else. There's nothing else adjacent to it. So it's going to be all by itself. This 0, we can make a group of 2, and we can make a group of 2 going this way, or a group of 2 going this way. It's, oh, no, no, no. We can make a group of 4. Look, I missed this one. So if we wrap around right here, that makes a group of 4. So that's better. Now remember, your groups can include things that were in other groups as well. You just want to make the biggest group as possible. Okay, so that's good. So we have 2 groups of 4 and 1 group of 1. A group of 1, not so good, but we'll deal with it. So a group of 4 should have 2 variables. And remember, it's the dual of the sum of products. So wherever we had a 1, we'll have a complemented variable. Wherever we have a 0, we'll have the variable uncomplemented. Where before we had products, we'll have sums, and vice versa. So this bottom row has x3 equal to 1 and x4 equal to 0. So that'll be x3 bar plus x4. This group of 4 has x1 equal to 1, so that's an x1 bar. And what else does it have in common? The other thing it has in common is x4 equal to 0, so that'll be plus x4. Okay, then this last one, it's a group of 1, so it will have 4 variables, and we just read it from the column and row numbers. So x1 plus x2 bar plus x3 plus x4 bar. So that would be the product of sums. And so this was our sum of products, and this was our product of sums. If we wanted to, we could figure out the cost by looking at the number of gates and the number of inputs into those gates. And I will leave that to you as an exercise to figure out the cost of these and which one has the lower cost. Oh, one last thing I wanted to note is that notice in this one, we did not have any circle that included this D. And in this one, it turned out that we did use all the D's. But if you don't need it, you don't use it. And notice in this one, we use the D's as zeros because it helped us that way. And in this one, we use the D's as 1. So they're like a wild card. They can be whatever you need, but you don't have to use them.